So welcome to my work solutions for the WJEC, also known as Eduqas past papers. As you can see, it's the November 2023 series. They call it Component 2. We know it as Paper 2, but most importantly, it means Calculator Allowed. Let's get on with it. For question 1, when you're doing fractions, it's the bit you're interested in. So in this case, for the shortbread recipe, we're interested in the sugar share, which comes third. The number we're looking at is 2, and the fraction is out of the 3 other proportions added together, 4 plus 3 plus 2. So 2/9 of the recipe is made up of the shortbread biscuit is made up of sugar. For part B, one of them where you can easily get yourself into a mess. If you are one of those people, get it organised. If you get a problem organised, you're halfway to solving it. We're told 1400 grams of flour. Of course, you're allowed to use a spare room down here, because all you're looking for, whether you've gone horizontal, doesn't matter. You're looking for your multiplier. 1400 divided by 4 means the multiplier is 350. We're being asked for the share, which is butter, 3 times 350, and we are asked to leave it in grams, so don't bother changing it to kilograms, 1050 for the final answer. Number 2, we've got Lucy buying a car, so we refer to the initial investment of any situation like this, the capital. Always for me worth writing your capital down. The car depreciates by 18%. We need a multiplier. To get your multiplier, I always say, if you start with a pound, think of percent and pence. They're interchangeable. 1% is 1 pence of a pound, and vice versa. They are literally interchangeable. Think of 18% as 18 pence and take it away. You don't have to do that level of working out. Your calculator or your brain can sort that out, but your multiplier is 0.82. That's for 1 year only. Power of 1, but who cares about that? The following, though, is a 15% multiplier. Same process. Take 15 pence off a pound, you get to 85 pence. So the multiplier is 0.85. Now it says 9 years there, but don't forget 1's already been done. The 0.85 needs the power of 8. If you bash all that in your calculator, you should get, and we'll go nearest pence, £2,737.17. Don't celebrate. That's not your answer. It says by how much has the car decreased in value. This is the new value of the car. We need to do 12,250, the original price minus the final price gives us the decrease in value of £9,512.83. And there we go. Number 3, estimating the mean. The only thing you care about in the top 3 lines is the number 70, because ultimately you're going to need to divide something by 70. And that something, when it comes to these estimating the means, is your total. Some teachers, I'm sure, call it sigma, sometimes even sigma fx. Who cares what you call it? The fact is, you need the midpoints. Get your halfways. 62.5, 60, yeah, that's a 2, obviously, 67.5, 72.5, 77.5, and 82.5. They're all widths of 5, so you just go up in 5s. Each of these midpoints is our guess. So, for example, these 19 fish, we're guessing that all 19 fish are 62.5. That's why it's called an estimate. Estimate doesn't mean pull a number out of thin air. It just means find the least worst possible answer kind of situation. Grab your calc, top line times top line, and so on down. 1187.5, 1147.5, apologies, I'm trying to be fast. 1667 with a 0.5, yes, that's a 7. 775, thankfully no 0.5. And the last line you can do in your head. That tells us that the sum, when you add all these up, the sum is 4,860. Needs dividing by 70, as already mentioned. Never divide it by 5. You'll get an answer that doesn't make sense. You'll get an answer above 85. That does not make sense. You divide by the number involved in the question, not the number of lines. And here it's 70 fish. Round it off however you want. 69.4 is fine. I've gone for 69.43 and it's in centimetres. Regan thinks the median length of the fish. Now the median will always be the middle one. Now depending on how you've been taught, you'll think that the median is the 35th fish, because that's half of 70, or some of you will have been taught to add 1 and then halve it. It doesn't matter, because as you can see, if you look at the first 2 groups, you've got 19 fish there, up to the right to the top of your second group down, it includes the 36th fish. So no matter which way you've been taught, it doesn't matter. Is Regan correct? No. Give a reason. Well, because the median is actually in the group below. So words, in your own words, the correct median is in the group 65 to 70. On we go. Number 4. So Jan's cutting stuff out of a piece of card. Well done, Jan. Whenever I read these questions, there's only one thing you care about. Is it area or is it perimeter? And because we're cutting bits out, it's area. So before you even read on, I would be looking at multiplying these numbers. Now, turns out this is actually only needed for part B, but who cares? You're guaranteed to be needing this. So what are we actually doing? She's cutting circles out. Circles with a radius of 6. But we're going to be caring about how many, not radii that fit in. We're interested in how many diameters fit in. Well, left to right, 12 goes into 96, 8 times. And the diameter is the same, obviously, vertically. So also 12's into 60, 5 times. So she could have 8 rows of 5 or 5 columns of 8, however you want to refer rows and columns. Who cares? The fact is, she can cut out 8 times 5, 40 circles. And now we can start doing part B. We've already banked that the whole thing is 5,760. But she's cutting out a load of circles. Well, she's actually cutting out, as we've just worked out, 40 of them. 40 of what? 40 of a circle which has an area of pi times the radius squared. and that goes into your calculator. If your calc gives it in terms of pi, you'll notice not really bothered. As long as it's in centimetres squared, it's all good. So do make sure you type it in accurately. I get 1,236, and I've gone for one decimal place. Mark scheme allows a little bit. Either way, 1235.5 up to and including 1,238.4. Anything in between them, they're not that fussed about how accurate your answer is. Number 5, bit of algebra. Expand. If you do a grid, do a grid. If you go straight to the answer, fine but risky. I'll go for the reasonably standard loops. It's a quadratic, make sure quad, you do 4 loops, so 7x. That loop is 3x. And again, you'll have your own method, face foil. When I was at school, we did beginners, inners, outers, enders, which makes a heck of a lot of sense if you've never heard it before. Anyway, you need to simplify, adding your x terms together. There are 10 of them. On to part B. Pretty straightforward solving with a slightly non-standard answer, but who cares? Let's take away 4x from both sides, whilst also subtracting 6 from both sides. And you now divide by the coefficient of x, divide both sides by 3. Give your answer as a third. If you've gone for decimals, it must be 0.3 recurring, because obviously 0.3 not correct. Factorising part C. Hopefully you've been doing enough revision to realise what happens when it is something squared minus something which has been squared. The square root of y squared is y. Square root of 400, you may be lucky enough to know it. You might grab your calcs. It's plus and minus 20, no matter which way you've gone about it. But the key thing is it's called the difference of two squares. Make sure you do revise it. It's very popular for a little 1 mark. Sometimes comes up in those algebraic fractions where you're expecting loads of stuff to cancel off the top and bottom. But anyway, I digress. Simultaneous equations. Your choice. You could multiply the bottom equation by 7, which will give you a way of eliminating the x's, but I always like to keep them as small as possible. Leave the top equation alone and treble everything on the bottom line. We've got the y's to have the same number. Whoops, I've slightly miscopied it. It's a negative on top. That's important because we've got 3 of each, but your teachers, I'm sure, will have said same sign subtract. These are different signs. It's an add. The y's will disappear. So for the x's, we have 10 of them. And 26 plus 9, 35, excuse me. Divide both sides by 10 on your calc or in your head. Up to you. Now you move on. Always pick one of your original equations, and I always like to pick the easiest of the two, or the easiest looking of the two. Write it down, but replace your x with 3.5. How can we add something and it gets smaller? It's got to be a minus, and it's minus a half. Or 0.5, solve it any way you fancy. Number 6, scale factor. Doesn't matter what shape it is, you're looking for a common side, a side where you know both. Now, multiply or divide, no one cares. If you've gone from left to right, right to left, no one cares. I'm going to find that multiplier by doing final length divided by original length. So my multiplier is 2/3. And depending on which way round, you might times and divide by 2/3. You might do the reciprocal. You could be times and dividing by 3/2. As long as you do the right one at the right time, your answers for R and T will match mine. Let's do R first. I need to take the 7.6 and go backwards. I'm going to use 2/3, but because I'm working backwards, I need to divide by my multiplier. I get 11.4. Makes perfect sense. And for T, to find T, we're just going the standard route. I'll take the 19.5, multiply it, because that will make sure it gets smaller. I get the answer, a nice round 13. And on we go. Number 7. Bit of a wordy, but ultimately it's one of our old friends' hidden soccer tower. Okay, I always like to work with angles inside. I know some people might have drawn the triangle up here and all that malarkey. Not for me. The way I'd have gone about it is refer to that. And by the way, to do this, we are getting rid of the bumpy track and we're thinking of what is the hypotenuse as a straight line. We'll come to that in part B. That's 48, making the inside angle 42. I want the distance that Vaughan's travelling. I'm wanting the hypotenuse. I have the adjacent, and we're not bothered about the opposite, making this a C, A, H question. We're after the H. That means we need to do adjacent divided by C is the cos button of our angle. And again, like all Eduqas papers, they're not that bothered about how accurate. Mark scheme goes nearest whole number. I'm going to go 1076.5. When we come to part B, state an assumption. I've already alluded to it. We are assuming Vaughan travels all the way down in a straight line. He doesn't, as you can see here. We are avoiding any assumptions of any drops, any peaks, and also we're looking from a side slice of the hill. From top to bottom, he could be zigzagging like a slalom skier. He could be travelling, well, it's certainly not going to be a straight line. He is going to be travelling a longer distance. That's your part double I, by the way. So state an assumption. We've said that he's cycling in a straight line. That's our assumption. He's going top to bottom, most direct route, no bumps, and so on. If your assumption is not correct, well, it definitely isn't correct when you compare it to real life. There's no way he's cycling in a perfect straight line. That means he's going to cycle further. Or you could, apologies, I'm rubbish with electronic pens, as you probably know, or anything along the lines of the real answer would be above 1076.5, etc., etc. Like I always say for these wordy one markers, you don't have to fill all 3 lines. That would take up way too much time. Get straight to the point. The assumption is that he cycles in a straight line, and if it's not correct, he cycles much further. End of conversation. Don't waffle. Number 8, we are making jewellery. We don't care really, but it's the 5% discount. We do not know the original price. We know the final price. When you have a situation like that, we also know the multiplier. I've mentioned on the question on Lucy and her car earlier. If you're reducing by 5%, your multiplier is 0.95. But when you do not know the original amount, it's a reverse percentages question. So although we refer to it as a multiplier, you need to divide by your multiplier to work it backwards. Into your calc, it's £1,528. But yeah, get revising. It's a very common exam topic, like a lot of them. Reverse percentages, absolutely key skill. Part B, as you can see, we're talking about density. Whenever I see one of those words, whether I see the word density, mass, volume, or any combination, get writing down DMV. That line, because you can read all the above, but it's not until down here that we've got something more important going on. Calculate the mass of each piece of jewellery. We want the mass, and something's being melted down to make 200. We're going to end up dividing by 200. The question is, what are we going to end up? Well, it's a cuboid. We'd like to know its volume. We normally do, but not in this case. Volume, its length, width, height, whatever you want to call it, depth, you've got to multiply them all. Earn your first mark, find the volume of the cuboid. I get 236.52 centimetres cubed. Next, we'd like to find the mass. We need to take this and multiply it by the density, 10.49. That will give us the mass. And that mass is 2,481 and a load of nonsensy decimal points, as you'd expect. But whatever you got, you divide it by 200 and round it off appropriately. I've not written down, unfortunately, how much leeway the mark scheme gives you, but there's bound to be a little bit of up and down allowed. Number 9, we've obviously got a very long-winded, whether you call it scale drawing, loci, constructions, or whatever. It's worth 6 marks. It's worth taking your time over. Waffly, wordy stuff at the top doesn't tell us anything of any interest at all. As you can see, yes, I've cheated. We'll come back to that in a sec. The only thing we care about in the top portion is the scale, 0.5 centimetre to 1 metre in real life. Amy spreading grass seed, good for Amy, not bothered. Grass seed will, again, not bothered. All we care about are these 3 restrictions here. It must be at least, in other words, more than 8 metres from the water feature. You need to grab your compasses. 8 metres will be 4 centimetres on your diagram. Set your compass so it is 4 centimetres from metal point to pencil point. Draw yourself that arc in there, and we're looking for that side of that line. Part 1 done. Nearer to the birdhouse, there's the birdhouse, than the tap. How do we know where's nearer? You need to bisect it. It's a perpendicular bisector. You grab your compasses, pairs of compasses, and you draw a semicircle, like so, over halfway, don't forget, with your metal point on the birdhouse. Then put your metal point on the tap. Then flip it around, metal point on the birdhouse, and about a semicircle. Joining them up gives you a perpendicular bisector, but you do need to make sure you go all the way to the edge of the garden. Finally, nearer to the hedge than the wall. The hedge is a straight line. The wall is a straight line. You need the halfway point of two straight lines, means an angle bisector. You grab your compass, metal point on the corner where the hedge and the wall meet, and I always draw about a quarter circle. Don't reset your compass, pick it up, metal point on there, small arc, metal point on there, small arc. Don't just get them joined up for your angle bisector, you've got to keep it on going. We need to be that side of the line because it needs to be nearer the birdhouse. We need to be outside of that circle because of the water feature, and we need to be nearer the hedge than the wall. That knocks off that bit there. And don't take too long shading it. 6 or 7 straight lines will suffice. I call it R out of habit, but a very long-winded one, that one. Take your time, nice and steady, 8 to 10 minutes, perfectly reasonable for a question like that. Number 10, rearranging, sometimes known as transposition of formula. If you want to make either subject get rid of everything else, we get rid of a minus 3f by adding 3f to both sides. We want e on its own. We divide by the number next to it, and we get the correct answer. G plus 3f, with or without brackets, no one cares, divided by 4. It's only worth 2 marks. It's just 2 steps. That's all you need to show. Number 11. They've put it in bold. Things are written correct to the nearest centimetre. That makes this an errors or bounds question. Don't read on. Don't carry on the waffle. 38 centimetres. The upper bound and lower bound, if you've been rounded off to the nearest centimetre, you go up and down by half a centimetre. 7 boxes. Each box has a height of 45 mil. Correct. Same again. 45. Whoops. The upper bound, add on half a millimetre. The lower bound, subtract half a millimetre. What is the largest possible gap? So in this context, I would argue that the largest possible gap is your best case scenario. So our best case scenario is when the thing which we are filling in, the stacker, whatever you want to call it, is as big as possible, and the things we're putting into it are as small as possible. But notice there's a conflict. You either need to turn these centimetres into millimetres or these millimetres into centimetres. I'll go for the former. Centimetres, best case scenario, it's 385 millimetres. And the gap, how do you find a gap? We find the difference. We're putting 7 of these smaller boxes using the smallest possible value, and that gives us the correct answer of 73.5, and you should specify millimetres, and obviously you might have got 7.35 centimetres as your answer. Also correct. Number 12. That equation has only one positive solution lying between those numbers. It's one of them change of sign questions. substitute the lower one in, 1.81, substitute the upper one in. Grab your calculator, be careful, use brackets. You should get, it's only 2 marks, don't need to show that much working out. You should get 0.031-ish and 0.119-ish. Now, if there was a solution between these points, it's a cubic, it's a continuous function. If you're crossing the axis before and after, you should get positive, negative, or negative, positive, otherwise known as a change of sign. We haven't here. No change of sign. Whoops. So Akriti is wrong. It's a no from me. Number 13, my usual cheating, because drawing these lines takes too long and life's too short to watch me be rubbish with technology. So all the waffle at the top, no one really cares. We've got the diagram, they've drawn it for us. Find the median. Don't be, it's tempting to look at the 60 if I'm honest and go for 30. Nope. There are 50 students. You need to draw your median at the halfway point, student number 25. As you can see, even wonkiness allows, I get 39, mark scheme allows 39 or 40. For the interquartile range, a quarter of 50 is 12.5. Treble it to get your upper quartile at 37.5. Go along and down. Yes, folks, do draw your lines in. It counts as you're working out. They will be using it. Okay, I get 51 and it's kind of just below 31. I'll call it 31 to give me 20 for my IQR, and mark scheme allows one either way, 19 to 21 inclusive. The next bit, I'll stay on this chart. The next bit says what percentage of pupils took longer than 62 minutes. Well, in order to find the percentage of students, you need to know how many students. You need to go this time to the x-axis, find 62 minutes, up to your graph, along. As you can see, my reading is 43 students, and because we're wanting those that took longer, that's the outside of the graph. So we're not going to use 43. There are 7 students who would be above that line. It's 7 out of the 50. Times it by 100. 14%. Again, plus or minus 1 for the mark scheme. Part B, because they love these things, 5 more marks. We have a summary. I've not drawn it in advance because I can do the ruler. Follow it through with one step at a time. The lowest is 12 minutes. Find your line, get it on, and I'll just nudge it up. 12 looks good. Lower quartile, that's the lower line of your box, 31. In it goes. It's a bit off. I'll budge it up to the right. That'll do. Median 45. Get it found. Hopefully my eyes are okay. Just a bit to the right. That'll do. The greatest is 65 minutes. Again, squint with my eyes. I think that's 5 little blocks. But the next thing is the interquartile range. They haven't told us the upper quartile. We need to do lower quartile plus the interquartile range. That gives us 55 minutes. They don't make it easy for me. On goes our lines. Doesn't matter how fat, how wide, whatever you want to call it. your box and whiskers are. Mine will do. If yours is narrower or wider, no one cares. I've made a deliberate mistake there, haven't I? No one saw it. It's okay. No one was watching. Literally. And there we go. That will do the job for me. Making 2 comments, it does actually give you the clue to talk about appropriate average, or the comment must include a measure of spread. So firstly, talk about the median. Any statement saying that the median of these is at 45 and the median for the year 7, for school A, was 39. So you've got the comparison. School A has a median of 39, school B has a median of 45. There's your sentence. On average, school A was quicker, or school B was slower, or had more time, etc., etc. Comment 2. Do a similar thing with the IQR. If you compare the interquartile range, which is 20 for school A, the interquartile is 24 for school B. When your interquartile range is lower, that means you are more consistent, or you had less variety. Or flip it on its head, school B was less consistent and had more variety. Like always, only worth a mark each. Don't feel like you've got to fill everything. Get straight to the point. On average, A had a shorter time, they were quicker, and overall, A were more consistent because they had a lower IQR. Number 14 looks like 3D trigonometry, because it is, but it's actually 3D Pythagoras. Why is that? Calculate the volume of the pyramid. The volume of the pyramid, you can flick to your formula book, is a third multiplied by the area of the base. It's square, so it's 9 squared, and it's then multiplied not by 12, it's multiplied by its vertical height, which we don't know. But we can draw in a nice right-angled triangle. I know this is why I don't use electronic pens to draw cumulative frequency graphs. But anyway, 12 on the hypotenuse. Notice that distance there. It's the midpoint. That's what the vertex is. It's literally the halfway point. So that's 4.5. I'm reluctant to put h on there because h is usually reserved for the hypotenuse. So let's call it x. And to find x, 12 is the hypotenuse. We need to do 12 squared minus 4.5 squared. My calc gives me a lovely surd, 3 root 55 over 2. But who cares? Decimal equivalent is fine, because all we're going to do, keep that in your calc screen, don't clear it. Because all we're going to do, we've got the height, plug it into the formula. Out it spits 300.356-ish. I'll round that off to 300.4. And the mark scheme's pretty generous, 299.7. And I'm right on the upper limit. So there we go. Onwards. Number 15, we've got Cody. We've kind of got a probability tree, but no need to draw the probability tree. If we were drawing the tree, we'd have red followed by red. That's the only branch we're interested in. First two are red. I've put the times in because that's all we need to do. First sweet is 8 red out of 17 sweets, but he's then eaten one. We're down to 7 red, 16 sweets. Grab your calc or do it without and pre-cancel. As long as you get 7 over 34 or an equivalent fraction or decimal, it's all good. Calculate the probability that Cody eats 2 sweets of the same colour. We've already done red. We just need to add it to green. Red is 7/34. Green will be 9/17. And then we're down to 8/16. Let your calculator do all the heavy lifting. 8 over 17 or equivalent fraction decimals. On we go. Number 16, one of them that can be off-putting. Don't let it. The fact is, if you knew the numbers, you would start by adding the parallel sides and halving them. So let's do it. The x plus 1 and the 2x added together gives us 2x plus x plus 1. You add the parallel sides, you halve them, and you multiply by the perpendicular distance between them, also known as the height of the trapezium. That's the formula for the area. We know it's 59.5. That's it, folks. On we track. Get rid of the half by doubling both sides. You'll never guess what 59.5 doubled is. And now we can expand these brackets. The half's gone. We have 3x times 2x. We have 1 times 2x. We have 3x times -3. And we have +1 times -3. We now just need to tidy up. And obviously use whatever technique you normally use, whether it's loops, grid, anything. Tidy it up. We do indeed end up with what we were asked to show. But that's only worth a couple of the marks. It says, and hence find the height of the trapezium. The height, by the way, is not the number we find when we find x. The height is 2x minus 3. So when we found x, we're going to need to double it and subtract 3. How do we find x? It's a quadratic, folks. No one saw me miss that. We are going to subtract 119 from both sides. And we are not going to dream of attempting to factorize this nonsense. It doesn't factorize. Go straight for the formula. A is 6. B is -7. C is -122. So we get minus B minus -7. Help your calc out. B squared is -7 times -7. -4 times A is -24 times -122 is +2928 all over 2 lots of 6. Now, when we do the minus bit, we get the answer -3.96. Not possible, because that'd be a negative then. There's no such thing as a negative length. We are rejecting the negative answer. We're not interested, and neither is the mark scheme. We only want the positive solution, which is 5.13-ish. get it into the aforementioned, times it by 2. Whoops, what am I thinking? Times it by 2, and then subtract 3, and bosh, 7.26 for a right old doozy of a question 16. Number 17. What a weird question. It's a clock, but not as we know it. It is ultimately, folks, arcs and sectors. I drew a little diagram for A. The hour hand has a length of 11. We've got that. Find the area of the sector. So when this moves like so, it's basically travelling, as they've said, 131 degrees. This sector has a radius of 11. So this horrible wording is really just saying find the area of this sector. It's pi r squared. That's your full circle. We haven't got a full circle. We have 131 360ths of the circle. I'll just round it off straight away. 138.3 millimeters squared. On to part B for a very weird part B. The minute hand has length y, so let's get that in. How far does it go in 21 minutes? Well, 21 minutes, there's 20 past, so we'll call that ish. What we're going to do though is we're not going to refer to that as degrees, we're going to refer to it as, because in an hour it will go all the way around, because it's a minute hand. With a minute hand in 60 minutes, it travels 360 degrees. So, in 21 minutes, it travels 21 60ths. Or you could scale it up, obviously, 126 360ths. That would be your angle. And if you've done it that way, not a problem. All we care about is we multiply that by the formula for the circumference of a circle, either 2 pi r or pi d. 2 times pi times the radius. It's not 11, that was the previous one. I'll wakey. We can't do the pi and the y on our calc. We are actually told to do it in terms of. We just need to press 21 60ths times 2 on our calc, and it'll do all the cancelling down for us. 7/10, or the equivalent of. What a nasty little strange question that is. Don't like that. Not a fan. Number 18, we have a garage, but who cares? The keyword inverse. We can write a formula. The waiting time t is, inverse means a number divided by the square of the mechanics. There we go. Let's sub in the numbers we know. Mechanics is 3, so I'm going to square it. The waiting time is 38. I can now find K. K is 9 lots of 38, 342, and we have our formula. Except I've forgotten to replace K with 342. There we go. Looks better now. Part B. Waffle, garage wants to reduce by no more than 12 minutes. We're going to interchange these. So the formula is now m squared equals 342 divided by time. We want 342 divided by, they want the waiting time to be no more than 12 minutes. That means we're going to sub it in and then question the context. All that malarkey, don't forget to square root it. We end up with M being 5.338-ish. But, first of all, you can't have 5.338 mechanics. So, it's not one where you round down to 5. If you round that down to 5, that number 12 will be higher. The number of mechanics required must be rounded up to 6. Hope that made sense. Nice little contextual proportion question there. So number 19, I'd argue reasonably obvious because it's triangles, they're back to back, there's no right angles. It's double sine rule, cosine rule. Let's see what we're needing. The key to these questions, if they share a side, that's always going to be your first target because it's almost like find that first, then carry it on. Let's work out what we're after. Calculate the size of CBD. Let's get that on there. Let's call it X. But although that's where the answer is, we know because it's 7 marks, we're not going to get there just straight away. We're going to need to use the first triangle. We've got 2 sides. We've got the angle between it. It's the cosine rule. Off we crack. Y squared will equal the 6.4 squared added to the 8.3 squared minus 2 BC times cos A is just the angle between them. It is coincidentally A here, but don't rely on their labels. It's not going to work over here when it's B, C and D, is it? So don't rely on their labels at all. We stick all that into our calculators. Whoops. And hopefully you agree that it spits out 75.26-ish. And then we square root it. We're getting 8.675-ish. Let's get it on. Now, we've got one of them situations where you've used the cosine rule. You might need the cosine rule again, but it's more likely to be the sine rule. In fact, we have an angle and the opposite side. It's definitely a sine rule question, but we can't directly find X. We're going to need the angle over at D. In fact, let's stick to capital D, shall we? There we go. If we find D, let's say D is 40, you then use angles in a triangle. So not a problem, but let's crack on. It is the sine rule question. We can say that D divided by, sorry, it's an angle, sine D, divided by the side which is opposite, 8.675, is equal to, we've gone for angles on top, so it's sine 68 divided by the angle, sorry, the side opposite is 11.1. Now I'm a fan of going like this on my, we need to multiply both sides by 8.675, and all this shebang in our calculators should be giving us 0.724-ish. But that's obviously not an angle. You need to find D, which is shift inverse or second function, whatever you want. It's inverse sine A and S. Use your A and S button. Goes a bit neglected too much nowadays. So that angle is 46.44. We need to take that angle and the other angle of 68 away from 180 degrees and we're home and dry. 180. Take away the 68. Take away the 46.44. And I'll now go to one decimal place. 65.6. What's next? Number 20. Inequalities. They've already done one of them for us in the table. That's that. What we're interested in are the equations of the other two lines. We have a dotted line. We'll worry about that in a sec. What it is a vertical line, which is x equals passing through -2. The equation of this line, y equals mx plus the intercept of c, well, it crosses at 1. The question is, what is its gradient? Find a nice little triangle. For every one along, it's going up 3 units. It has the equation y equals 3x plus 1. How are we going to write it on the inequalities? For the x bit, we are wanting to be bigger than it. We need greater than -2. But because it's a dotted line, we don't put in the equals to part. It's just a greater than, not a greater than or equal to. For the other line, we are wanting the height. We're shading above that line. We need y to be greater than. This is a solid line. We do need the equal to. And there we go for the first bit. Next, part B is saying, show that the equation of the perpendicular bisector. As we know with show questions, it really means do. So we've got this mythical perpendicular bisector. If we're going to find the gradient of it, we're going to need the gradient of this line. Let's do that first. The gradient from A to B is changing wise. That's 10 down to -6. That's down 16 divided by changing x's. That's -3 up to +1. That's a change of 4. So the gradient of this line is -4. It's a bisector. We need the midpoint. For the midpoint, you average the x coordinates. So that's -3 added to 1. That gets halved. And the y coordinate, we add the 10 to the -6, which also needs halving. We can move on. The midpoint of AB is, use your calc if you need to, if you're not confident with your negative numbers, but you should be getting -1 for the x coordinate, 2 for the y coordinate, and the gradient of the perpendicular, negative reciprocal. Flip the 4, you get a quarter. Change the minus to a plus. There we go. We've got the gradient of this line. We've got a coordinate it goes through. Y equals mx plus c. The y coordinate is 2 when the x coordinate is -1. The gradient is always a quarter. We now just need to find our intercept. Grab your calcs, find c by doing 2 plus a quarter, 9/4. We've now got everything we need. the equation of the perpendicular bisector is y equals the gradient x plus the intercept. But as you can tell, what you're asked to show, everything needs multiplying by 4. And yeah, I do like to write that on my exam papers. I would advise anyone else to. Times by 4, times by 4, times by 4. Job's a good un. On we go. Number 21. A wordy Venn diagram, but as always, one line at a time. For me, the most important phrase is the middle. The intersection of A and B is 0.07. We can now get rid. The left-hand bit next. The probability of A and B together, all of it, is 0.66. Which means the outside of it is 0.34. That's the first bit that tells you 2 of the sections. What's next though? The probability of A intersection B dash. There's 4 sections on a Venn diagram. 1, 2, 3, 4. Which ones are we interested in? We're only interested in the crossover between those inside of A, that's them, and the outside of B. That's outside B, so is that, and they're not. So the only bit we're interested in is the moon, as I call it, of A. That's the 0.31. In it goes. You could do that by shading. I prefer to do it by numbering or lettering. Now you grab your calc. The numbers inside this Venn diagram should add up to 1. 1 minus these 3 numbers is 0.2 with a rubbish 8. That's better. The probability that B occurs and A does not is actually that particular section. That's where B does happen and A doesn't. There we go. Now on to part B. I'll do this one. I did the previous bit by numbering. I'll do this by shading. Doesn't take you long to draw a little diagram, a replica. Union means all together. So I'm wanting not just A. There's the A circle. I'm also wanting everything that is outside of B. So we now include this. It's just not that bit we're after. In other words, we're after everything except the 0.28. It's 1 minus 0.28. We wrap up with a 0.72. And on to the next one. Number 22. Basically, it's telling you, please complete the square. So let's crack on. Halve the number next to x. It's -2. Square it and take it away. And now simplify. Leave the brackets alone. -4, take away 1. We go down to -5. Now we try and draw diagrams live. Hope you're ready for this. What's happened on the equation? An x has been replaced with x minus 2. If you don't know your transformations, this is a translation. If it was a plus or minus 2 on the end, that would affect vertical. This is not. This is a horizontal movement. The question is left or right. Horizontally, it's always the opposite way round. We need to move this graph right 2 units. That means this coordinate heads to the origin. The minimum point, the x-coordinate, ends up at 2 minus 1. And this point of intersection goes from having an x-coordinate of 2 to an x-coordinate of 4. And now I do a really bad job. It'll do. It's got marked clearly the coordinates of intercept with the x-axis, with the axes. Needs that labelling. Needs that labelling. That wasn't necessary. It's just a bonus. And make sure you've got the same general shape. Bit of wobbles, not that bothered. Part double I, what's going on here? We have taken the x and it has been multiplied by minus 1. Whenever you've got a negative multiplication, whether it's the x-coordinate or the whole equation, you have a reflection. But is this a reflection in the y-axis or the x-axis? Well, let's have a think about this line. If you only multiply the x, the number in front of x, the gradient, by negative 1, that will only affect the gradient. It will not affect the intercept. It will stay. This is a reflection in the y-axis. Because the intercept stays, the gradient is what changes. That coordinate of 5, 0 is going to reflect to 5, 0 over here. Grab your ruler and make a better job of it than mine. That's a little bit steeper, isn't it? Let's do that. That'll do. Doesn't have to be a work of art. As long as you have this labelling, you'll get the 2 marks. On we go. Number 23. Looks like a horrible circles question. Not as bad as that. The equation of a circle, don't forget, any point on a circle can actually be described using Pythagoras. That's what it's all about. What the hell am I doing? Why? We can simply say that x squared plus y squared equals the radius squared, and the radius is 5. You can write it as 5 squared if you wish, or 25. Mark scheme allows both. Now part B is pretending to be massively difficult. It's not. Find the coordinates of the point of intersection of the tangent to the circle. In other words, folks, just a horizontal line that I'm putting in a really bad place. That'll do the job. There is the tangent to the circle. It's just a horizontal line. Horizontal lines have equations. This is y equals 5. And this line, y equals 2x plus 3. Don't care how accurate my diagram is. That'll do the job. It illustrates what's going on. How do you find the points of intersection? It's simultaneous equations, but look how easy they are. you've got a linear and world's easiest linear. We're simply going to stick y equals 5 into this equation and solve it. Take away 3 from both sides. Our x coordinate is 1. It wants us to give our answer as a coordinate. Make sure you do as you're told. X is 1, y is 5. Yeah, I'm afraid it was that easy, but boy, is it pretending to be a lot more difficult, and you can certainly very easily miss that question out, thinking it's a lot worse than it actually is. Yeah, typical Eduqas there, as you can see. Fairly long paper, 2 hours 15. Some really difficult ones at the end, in my opinion. But the final question, not as bad. I thought that Venn diagrams was tricky. That was very tricky. And that was your standard trickiness at the end. Overall, yeah, slightly towards the tricky side, if I'm being honest, but plenty of marks early on to get yourself going. Hope that's helped on both papers. God knows what's next. I'll see you when I see you.